So in this video we're going to rig the rockfish so it can swim in a believable way. Now when approaching the rig we can break the movement of the fish down into three specific areas. First of all, we've got the swimming motion of the body and tail. Secondly, we've got the movement of the head, which will include movement of the eyes, mouth and gills. And finally, we've got the movement of the fins. Now the fins are actually quite interesting because some of them will need to be animated independently, for example the spiny dorsal fin and also the pectoral fins. But the movement for the rest of the fins is really a result of the swimming motion of the fish, so we'll have to rig those in a different way. So the first thing to do is to hide all of these textures so we can see the mesh clearly. So let's go to the shader tree, select the base material, and we'll just drag and drop that to the top of the shader tree. We'll go over to the setup tab, we've got the right hand view. Now we can't see the fish very well here, so I'm going to hit O to bring up viewport properties, and I'm going to turn off lights. I'm also going to turn off cameras and also texture locators. Go over to drawing and control and make sure that overlay drawing is active, and also activate show weight maps. So we'll start with the swimming motion of the fish, and that can be created by using a skeleton. So let's go to item mode and also setup mode. Go to the setup tab and run the skeleton tool. I'm going to zoom in to this area here, click in the viewport, and then click again. That creates our first joint, and it needs to be placed in line with the back of the head. Now that first joint is going to be the root of the skeleton. So then zoom out, and now we need to lay down three joints along the body. So click once, twice, and the final one should be just right at the base of the tail fin. And each of those joints needs to be roughly the same size. Now we also need a joint that's going to allow us to move the head from side to side, and that needs to be parented to the root. So zoom in, select the root, click in the viewport, and then place this locator at the base of that joint, and then click the front of the head to create that joint, and then hit spacebar to drop the tool. Now as we continue to build this rig, it's really important to keep everything nicely organized in the item list, and also make sure everything's named correctly. So to organize things, I'm going to start by adding two group locators. I'm going to call one RF mesh, and I'm going to call the other one RF rig. So the mesh and the rig are going to be completely separated in the item list. So select the rockfish mesh, and I'm going to drag and drop that into RF mesh, select the first skeleton joint and drag that into RF rig. So now we need to name the skeleton, so we'll call this one root, and body 1, body 2, body 3, and we don't need to see this last one, so we'll just hide it, and then we need to rename this one head, and again we don't need to see the last one, so hide that one. Now before we bind the skeleton to the rig, we need to first of all make sure that the root joint is zeroed on X, and we can see it isn't here, it's got a value of 63 millimeters. So I'm just going to type in 0, and then if we double click the root joint to select all of the joints, we need to make sure that the position and rotational channels are all zeroed out, so the start of any rotation will always be 0. So just come down to 0 and we can just select all. So now we can bind the skeleton to the mesh. So select the root joint, hold down Control and select the mesh, come down to Deformers, run bind, and we're just going to use the default smooth by distance type. Click OK. Now we can come out of setup mode. If we go to a perspective view, we can select some of these bones, we can see the weight maps, and if we just rotate them around you can see the mesh is deforming nicely. So again, we need to make sure that we keep naming things as we make them. So if we go over to the deformer list, you can see we have the normalizing folder in there which contains all of the deformers for the skeleton. We just want to rename the folder, so we'll just call that skeleton. Now, although we've got the joints bound to the mesh, we need to make sure that the deformation that's occurring is occurring in a way that we want it to. Now, for the tail area, if I select these three joints and rotate them, you can see that the swimming motion is really nice. But the problem is the body of the fish is quite soft, but the head of a fish is quite a hard, bony object. And you can see that as it's rotating, it's actually deforming in a very similar way to the body. So what I need to do is adjust the weight maps so that the head appears to be much more rigid. So to do that, let's select the first joint in the body. We'll turn symmetry on the X. We can see how that weight map is kind of bleeding into the head area. So let's come down to weighting. Let's run the erase tool. Make sure live deformers is turned off. Right click for your brush size, and we just want to paint out the weight, or remove the weight from the head area. So make sure you remove all of the weight for that head area, including the weight inside the gill, and try and make the area around these horns as smooth as possible. So now, when I rotate this joint, you can see that the head remains in place. So now we can look at how to animate other elements of the head, and let's start with the eyes. Now, for the eyes, they're basically spheres, and the central part of the eye needs to move, but then the deformation needs to fall off around the eyes. So we can achieve this by using a transform effector in combination with a fall off. So I'm going to start by selecting the rockfish mesh, right click, go add deformer, effectors, and select transform effector. So we can rename that locator, and we'll call it eye right. If we go to the display tab, we can reduce the size of it in the viewport so it's easier to work with. And now we need to change the position of that locator. So we need to go into setup mode. Let's go to top view and also to wireframe. Hit Y, and we can move that locator so it's centered on that eye. And we also need to rotate it so it's aligned to the eye. So then go to a front view and do the same on this axis. Now at the moment that deformer is affecting the entire mesh. We just want to isolate the effect to the eye area. So to do that we need to override it with a fall off. So in the item list, expand the rockfish mesh item, select the transform effector, right click, go to add override, fall offs, and select radial fall off. Now at the moment that fall off is positioned at the origin, but we need it to be in the same position as this locator. So hold down shift and select the locator, go to setup, and under match and align run item position. So you can see this now in the same place. So now we need to scale the radial fall off. So go over to item properties, and with the gang edit set to equals, we can just reduce the radius of that fall off, and we need it so it's going to cover the eye and also an area around the eye. Now at the moment the fall off is running from the center of the sphere to the outside of the sphere, and we don't want that, because when we move the eyeball we want the eyeball to maintain its shape. So to achieve that we need to increase the solid core value of the fall off, and we need to increase its size so it's the same size as the eyeball. So I've renamed the radial fall off to radial fall off eye right, and I've also renamed the transform effector to eye right. So now we need to create the same thing for the other eye. So to do that we need another transform effector. So select the rockfish mesh item, right click, add deformer, and select transform effector. Reduce the size of it in the viewport, Now we need it to be in the same orientation as the other transform effector. So hold down Shift and select the other locator, and under Setup hit Item Position, then hold down Shift again and select the other locator, and also hit Item Rotation, and then to get it into that orientation on the other side of the X-axis, just hit Mirror X. So now we need the fall off on that transform effector. So select it, right click, add override, and radial fall off. We need it to be in the same position as that locator, so hold down Shift, select the locator, item position, and we need to match the scale to the other fall off. So use the gang edit, set to equals, we'll set that to 25.6 millimeters. And we need the core shape to be the same, and I know that's 62.5%. So I've renamed those three new items to eye left, and now we need to make sure that the deformers are in the correct position within the hierarchy of the object. At the moment they're not parented to anything, but we want them to move with the fish, and in particular we want them to move with the head as it moves from side to side. So to do that we need to shift select those four items, and we'll just drag and drop them onto head. And just like we did with the joints, we need to make sure that their rotation and position are zeroed out. So go down to 0 and select all. So with those in place we can now check if they work. So let's come out of setup mode, so select one of the eye locators, let's hit Y, and if we rotate that you can see it works really nicely. But that's okay if the fish is in this position, but what if the head is rotated slightly? So let's select the head, hit Y, and we'll rotate it over, probably a little bit more than it actually would in the animation, and you can see straight away that we're getting some very strange things happening to the eyes. Now there are three reasons why this is happening. First of all, we need to think about the order in which these deformers are being fired. So if we go to the deformer list, we can see here that we have the skeleton, which is the normalized folder for each of the joints, and then above it we have eye left and eye right. Now the deformer list reads from the bottom up, so at the moment we have the skeleton being deformed first, and then the eyes are being deformed afterwards. Now these deformers are doing very different things. The two eye deformers are affecting very small portions of the model, whereas the skeleton is affecting the entire fish. So it makes sense to apply these localized deformations in the setup position, and once they're in place, then use the skeleton to deform the entire object. So to change this order of deformation, all we have to do is select the two eye deformers and place them below the skeleton, and you'll see the geometry change in the viewport. Now as you can see, the deformation still isn't right, but if we go over to the item list and select the two transform effectors and go over to properties, you can see that the deformation mode is set to world. Now having this deformation mode set to world is wrong because these two transform effectors are parented to the head joint that we're using to deform the head of the fish. And when we move that joint, we're going to be moving these transform effectors in world space, and that creates this double transform. So what we need to do is change this deformation mode to local, and when we do that you can see the eyes snap back into place. So let's check to see if these eyes are working now. So I'm just going to select this one, hit Y, and if I move the eye you can see it's deforming, but it's still not deforming correctly. So there must be a problem with the fall-offs. So if you select those two fall-offs and come over to properties, you can see a setting called use setup, and it's deactivated at the moment. Now with it deactivated, it means it's not using its setup position for the fall-offs, it's using their current position. Now because they're parented to the head joint in the fish, and the head is turned, it means there's an offset being applied to them. Now we have to remember the order of deformation here. If we go to the deformer list, we can see that the eyes are being deformed before the skeleton has any effect on the object. So what we need to do is to activate use setup, and now the eye is deforming perfectly. So next we can move on to the mouth, and we can rig this quite easily using a transform deformer. So I'm going to select the rockfish, go to polygon mode, and select 2 polygons at the front of the jaw, hold down shift and hit the up arrow to expand the selection to about there. Then we'll turn symmetry on the X, hold down control and just deselect those polygons. And if you come down to deformers, under apply mesh deformer you can just select transform. As you can see, it places a locator at the center of the selection. So if you want to change that, we'll go to item mode, go to right hand view and also to setup mode. I want to change the size of that locator because it's far too big, so I'll just bring down the size value. Then I'll hit Y and I can place that locator at the base of the jaw. Now you can test that deformation just by coming out of setup mode. I can rotate that locator and it works fine apart from this sort of kind of bump we're getting at the bottom of the jaw. So what we need to do is change the weight map a little bit. We need it to blend out more. So to do that, under edit, I'm going to run a linear fall off and I'll drag it across that area. Go into polygon mode because we've still got those polygons selected. And I'm going to vertex map, weight tool. I'm going to set the value to 0 and then click in the viewport. You can see how that's blending out now. So drop the tool and remove the fall off by hitting escape. Let's go back into item mode and we'll test that deformation again. You can see as that jaw turns now, it's much smoother. So now we need to place that deformer correctly into the hierarchy. So go into setup mode, we'll rename that transform effector, we'll call it mouth. And like we did with the eyes, it needs to be parented to the head. So drag and drop that onto head. Go over to properties. Again, we need to zero out the position and rotation. And like the eyes, we need to change the deformation mode to local. Then we can select the transform effector. We'll rename that mouth. Then go to the deformers viewport and drag the mouth deformer so it happens before the skeleton deformation. Now when this mouth is open, I want the gills to be slightly open as well. And when the mouth closes, I want the gills to be in this kind of rest position. Now I can do that by linking or creating a relationship between the rotation of the mouth and a morph map. So I have to start by creating the morph map. So let's go to polygon mode. I've got symmetry on the X. Make sure rockfish is selected. We'll go over to lists, expand morph maps, select, click new map, and we'll call this gills. So now we can change the shape of the gills, but before we do it, I'm going to hit O to bring up viewport properties, go decheck overlay drawing, and that hides most of the rig. But importantly, we have to decheck enable deformers, and that will allow us to see our edits in this viewport. So we'll start with this gill. So select those polygons, hold down shift and hit the up arrow to expand the selection. We might want to hold down shift and select a little bit more of this. So I go to edit, fall off, run a linear fall off, drag a fall off across that selection, hit W, and then just move the gill out. Now just to create a nicer blend on either side, drop the tool, and with the fall off still active, drag it to that position, hit W, and then we can move that back down, and then we can do the same on the other side. So take as much time as you need shaping those gills until you end up with something that looks like this. So we've got this little bit of movement with the gills separating. Okay, so with that morph map selected, I'm going to hit O again, activate overlay drawing and also enable deformers. And now we need to apply that morph map as a deformer to the rockfish item. So I go back to item mode and under deformers, we'll just select Morph. So let's just change the size of that locator, and its position actually isn't that important. All we need to do is drop that into the group locator, so it's parented to the root of the whole thing. But importantly, we need to now link it to the rotation of the mouth. So under modifiers, bring up the channel links viewport. So the driver is going to be the mouth, so select that locator, hit load driver, and then select morph and hit load driven. So we want to create a relationship between rotation X and the strength of the morph. We want it to be a relationship, and then click add link. So when the rotation is at 0, we want the strength to be 100, so I'll just type it in there. But then if we click and drag on this rotation X channel, we can rotate the mouth up. So when it's at that position, I want the strength to be 0. The little square in the middle will go yellow, which means it needs to be keyed. So I'm just going to click on that to create the key, and then we can open up the graph editor from that button, and that's the curve for the relationship. We want it to be a linear relationship, so if we overdrive the rotation, the gills will continue to expand or collapse. So let's right click, have a pre-behavior of linear and also a post behavior of linear. So close the graph editor, hit escape to deselect the relationship, and now if we select the mouth and hit Y, as we open the mouth you can see the gills opening at the same time. So I've renamed that morph to morph gills, but there's one thing we haven't done yet, and that's if we go to the deformer list, we need to move the morph deformer below the skeleton group. So next we can look at the spiny dorsal fin. Now this area of the model is quite interesting because each spine needs to be separately articulated so that the whole fin can lay flat against the body of the fish. But this can be achieved just with transform deformers and relationships. So I've got symmetry on the X and I'm in polygon mode. I'll start the front and I'll select one spine and then a row of polygons on that side, and deformers, I'll hit transform deformer. Then I come along to the next spine, select that one, and again select a row of polygons on either side. Again, a transform deformer, go to the next spine and do exactly the same. And just keep going until you've done all of the spines. So when you've done all of them, shift select all of the locators, go to display and reduce the size of the locators so they're easy to select. Then go to item mode and also to setup mode. Let's go to the right hand view, and starting with the first one, hit Y and just position the locator at the base of each spine. So when you finish that, rename each of those locators spine 1 to 12, then shift select all of the locators, and we need to parent them to the root joint. Then in properties we need to zero all, so we zero out the position and rotational channels, and we also need to set the deformation mode to local. So if we come out of setup mode, we can then select one spine, and if we rotate it, we can see that the spine moves, but there's no blend between each spine. So to achieve that, we need to go to the deformer viewport, shift select all of the transform deformers, right click and normalize. So all of those deformers now become grouped and they're treated as a single deformer. So now if I select that transform deformer and move the spine, you can see we're now getting a blend between them. So rename that folder and we'll call it dorsal fin. And again, just like all of the other deformers, that deformation has to occur before the skeleton deforms the object. So we'll drag it below the skeleton folder. So now we need to rig it so the fin can fold flat. So we'll start by creating a new locator. I'll just reduce the size of it. Hit the Y key, and I'm just going to position it above the dorsal fin. And I'll call it dorsal controller. And we can just parent that into the rig. Now if I rotate it that way, it's going negative. So I know I can now create a relationship between the rotation of that locator and the rotation of each of these transform deformers. So under modifiers, open up the channel lists. With the dorsal controller selected, load that as the driver, and then select the first transform deformer and load that as the driven. So we want rotation X to drive rotation X. We want it to be a relationship and add link. So when rotation X becomes minus 90 degrees, the rotation of this deformer needs to go down to about there. We'll key it, open up the graph editor, and we want this to be a linear relationship, so just select both keys, right click and set them to linear. Spacebar to drop the tool, select the dorsal controller and just zero out the rotation. Then select the next transform deformer, load that as the driven, rotation X to rotation X, add link. Again, when that becomes minus 90 degrees, this one goes much flatter. Key it, graph editor, select the keys and set them to be linear. Again, spacebar to drop the tool, reset the rotation. Next transform deformer, load that as the driven, rotation X to rotation X, add link, and just keep going until you've linked up all of those deformers. So when you've done that, you can now rotate this locator and the whole fin will fold down flat with the body. Now we can approach the pectoral fins in much the same way. Again, they're quite spiny fins which act as paddles to kind of stabilize the fish as it's swimming. So select the rockfish, let's go to polygon mode. I'm going to turn symmetry off, and I'm just going to select these polygons on the top and on both sides. Under deformers, create a transform deformer. Then we'll select these polygons. Create another transform deformer. And finally, select these polygons. And create another transform deformer. So I've done exactly the same thing on the other fin, and I've renamed those locators pectoral right 1 to 3 and pectoral left 1 to 3. And now we just need to position them. So go to item mode and setup mode. Select one of the locators, and we just need to position that at the base of the fin. The next one. And do the same. And this one. today. You might want to rotate it around a little bit. So when you've got those three positioned, we can position the other ones by selecting that one, hold down Shift and select that one, and under Setup select Item Position, hold down Shift and select it again, Item Rotation, then hit Mirror X, and we can do the same with this one. And finally that one. Then Shift select those 6 locators, and we need to parent those to the root, and in Properties zero out the transform channels, set the deformation mode to local, and then like we did with the dorsal fin, we need to normalize them. So if we go to the deformers viewport, we can shift select those 3, right click normalize, and we'll rename that Pectoral right, and then we'll select those 3, right click normalize, and call those Pectoral left. So don't forget to place those 2 normalizing folders below the skeleton folder. And the last thing you might want to do is go through each of these transform deformers, and you might want to change the weight map at the base of the fin so we get a nicer blend between the fin and the body of the fish. So in vertex mode, I'm just going to select those points, go to vertex map weight tool, and I'm going to set a weight of 50%, click in the viewport, go back to item mode, and select these points, again vertex map weight tool, click in the viewport, and do the same for all the other transform deformers. So that's the basic rig in place, but before we can finish it off we need to keyframe the swimming motion because a lot of the rig actually links to it. So in item mode I'm going to select the 3 joints that make up the skeleton, and in item properties I'm going to set a rotation of 10 degrees on Y, and I'm going to key it. Then I'm going to move to frame 30, and I'm going to change the Y rotation to -10 degrees. So at the moment the tail is just swishing from side to side, and that's not how a fish swims. What we actually need to create is a delay. So the second joint is slightly behind the first joint, and the third joint is slightly behind the second joint. So to do that we need to bring the timeline up to reveal the dope track, and we can see our 3 key channels there. So to create the delay I'm just going to select the second one, move that along 15 frames, then select the third one and move that along 30 frames. Now that motion needs to be continuous, so I'm going to right click on the channel and open up the graph editor. If I select all 3 rotation Y channels, right click in the graph editor, set a pre-behavior to oscillate and also a post-behavior to oscillate. And now if I play the animation, the fish is swimming. Now as the fish is swimming I want his head to be moving from side to side slightly. Now what we can do is use the rotation of this first joint in the body and link it to the head. So select that first joint, come over to channels, go down to rotation Y and drag that channel into the schematic. Then select the head, go down to rotation Y and drag that into the schematic. Now if I create a direct link to those 2 channels and hit play, you can see that the head is moving in the wrong direction. It needs to be counteracting the rotation of that first joint. So I'm going to select that connection, hit backspace to remove it. So what I'm going to do is have to invert the value. So go add modifier, math, and select basic math multiply. So we'll link those into there. So we're going to feed that value into here, and we want to invert it. So we're going to multiply it by -1, and then feed that into the rotation of the head. Now if I press play, the head is going the right way now, but there's far too much movement. So we need to reduce this value. So I'm going to select that link, hit backspace again, and this time I'm going to add a basic math divide. So we'll feed that value into there, and let's divide it by 2. And that's a bit less movement there. It's looking a little bit better, but I think it only needs to be a very subtle movement. So I'm going to divide it by 5, and that's more like it. Now we need to do a similar thing for these pectoral fins. Now the thing about these fins is they need to act like paddles. So we need to rotate these 3 deformers on the fin, but there needs to be a delay in the rotation of each one. Well, we've already keyframed a delay through the body, so we just need to link each of these joints in the body to each of these deformers in the fins. So we'll select that first rotation Y, and actually we've already got that channel in there, so keep it there. We'll select the first deformer in the pectoral fin, and we'll take its rotation Y channel, and let's feed it straight in. Now that's moving in the right direction, but it's not moving enough. So what we can do, if I remove that link, we can add a modifier again, math multiply. We'll link that in, and we'll multiply it by 2. So now we've got much more movement. You can see how it's following the swimming motion. So now we just need to link the other ones up in the same way. So select the second joint in the body, and in channels bring its rotation Y channel in, and select the second deformer, bring its rotation Y in, go to add modifier, multiply, link it through, and multiply it by 2. And then we can do the third one. Oops. Link that one up and multiply that by 2. And now if I hit play, we have the fin paddling through the water and following the swimming motion of the fish. So for the other fin, we can just link them straight in. So we'll bring the 3 rotation channels in. Then we'll link that one to there, that one to there, and that one to there. So that's the rig in place, but it's very chaotic in the viewport. So what we need to do is tidy it up so we can only see the elements of the rig that we need to interact with. So we'll start with probably the most important thing, and that's the 3 keyed channels for the body, because an animator might want to change the timing of the swim. So what we can do is create a group. So I'm going to hold down Shift and select those 3 joints, go to the channel list, and I'm going to select the 3 keyed rotation Y channels. Then I'm going to go over to the groups viewport, I'm going to hit new group, I'm going to call it swim, and I want it to be created from selected channels. So hit OK, there's the new group. So now if I select that group, those keyed channels are automatically selected. Now what I'd like to be able to do is select that group from the 3D viewport. And I can do that. If I expand the command list here, you can see that the last command fired, or the second from last, was to select that group. So I'm going to highlight it and copy that command, and then I'm going to create a locator, change the size of it, and we'll just move that up to the back of the fish. And then if we go to assembly under command, we can just paste that command into there, hit return. So now when I select that locator, that group is automatically selected. So I'll rename that locator, call it swim channels, and I'll just drop that into RF rig. So let's hide what we don't want to see. Well, we can start by going to viewport properties and turning off overlay drawing. And then if we expand the rig in the item list, we can then select all of those locators, and under display we can turn visible to no. So we can do the same thing for the two radial fall-offs, but then we want to be able to select these locators more easily. So let's select eye right and eye left, and under display, under locator shape, change the shape to custom. We want to replace the locator with a sphere. We'll not make it solid, and then we'll just reduce the radius. If we select those two locators, locator shape, custom, replace these with a circle, and the axis could be X. And finally this one, okay, shape, custom, we could replace that with a rhombus. We could reduce the size of that. So just to finish off, like we did with the swim channel locator, when we select these locators around the head, we might want a tool to run, in this case the rotate tool. So first of all we need the command, so I'm going to select a locator and hit E for the rotate. We expand the command history, and there's the tool there, tool.set transform rotate on. So select it and copy it. Then with that locator selected, go to assembly and paste that command in there, and we'll do the same for the eyes and also the mouth. So now when we select one of these locators, the rotate tool will automatically run. So in this section we're going to animate the fish and then use Recoil's soft body dynamics to simulate the fins. Now in order to save the simulation we're going to have to export an MDD file, and to do that we need a plugin. Now Matt Cox has kindly agreed for his MDD export plugin to be included with this tutorial, so if you haven't got it already we need to install it. So in Modo, just go to System, open User Config folder, and then if you go to your content directory under MDD, got MCLX export MDD, select the two folders in there, copy them, and then paste them into your config folder. And then you need to close Modo and open it up again. And when you open it up, at the bottom of the Commands tab we'll have a thing called Toolbox, and in there there'll be a button for Export MDD. Now when it comes to animating the fish you can make it as complicated as you like, but for the purposes of this tutorial I'm going to keep it really simple and just do a simple animation of the fish swimming along the z-axis. So I'll start by setting the length of the animation. I'm going to make it 500 frames, and then I'm just going to animate the RF rig folder. So I'm going to key the Z position, and then at frame 500 I'm I'm going to have it at 2 meters. Now that distance is really dependent on the speed of the swim. So if his tail is swimming faster, you'd probably want him to move further. But that's quite a nice, slow, majestic swim. Now you want that swim to be a constant velocity, so select the channel and open it up in the graph editor and set the pre and post behavior to linear. So now it's just a case of layering animation on top of that. For example, the mouth could be a very slow kind of opening and closing. So let's select that locator. I'm going to key it on X. So let's go to about frame 60, maybe frame 72, and then we'll close it. Close the mouth, not completely, it's about there. And then frame 144, set it back down to 0. And if we open up the graph editor, again we can set the pre and post behavior to oscillate. So as the animation runs, his mouth will slowly open and close. Now with the dorsal fin and the eye, you can start to inject a little bit of personality into the character. So if I select the dorsal fin, I'll key the rotation X channel, so the dorsal fin down a bit. And as he's swimming along, it might be kind of gradually closing and opening up again. But at a certain point, I want him to see you swimming past, or you might get startled by something. So at that point, just move a few frames forward, and I want the whole fin to go right down. And then come up again. And then he swims on by, and it gradually moves up and down. So what I've done next is keyframe his right eye, so that when that fin folds down, his eye suddenly looks backwards as if he's seen something, and then it slowly moves forward again. So like I said, make the animation as complicated as you want. You might even want to go in and animate the swim channels so you could speed up, slow down, or even stop. Once you've got your animation in place, we now need to use Recoil to simulate the fins. So the first thing to do is select the rockfish mesh, then go to Recoil and click Make Soft Body. Now that will add 2 new items into the item list. You'll have the Recoil item, and if you expand rockfish, you'll have a soft body influence deformer. So we'll start by selecting the Recoil item. Now you have to be quite logical when you approach Recoil. For example, if the fish is swimming underwater, then gravity isn't going to be having much effect on it. So I'm just going to zero out gravity on the Y. And also, by default, Recoil sets the air density to be the density of air, but the fish is underwater. Now I'm reliably informed by the internet that the density of water is 1,000 kilograms per meter cubed. So I'm going to change the air density to 1,000. So we've defined the environment that the fish is going to be swimming in, but now we have to define the fish material itself. So select the soft body influence deformer. Now in properties, probably the most important settings are the springs settings. And again, you have to think logically. So by default, the structure stiffness is set to 100. So do we want it to be 100? Well, yes, we don't want the fish stretching at all. Then we have shear stiffness. So we need to think, do we want the polygons to be shearing? And no, we don't really. So I'm going to put that setting to 100%. Now, do we want the fish to bend? Well, yes, we do, because we want the fins to fold over. So we can have quite a low bend stiffness setting. So I'm going to set that to 15. Now, before we actually run the simulation, we need to tell Recoil what parts of the model need to be soft. And we can do that with a weight map. So let's go back over to the Model tab, and under Lists and Weight Maps, we'll hit New Map, and we'll call this Pin Map. So what we'll do first is apply weight to the whole object. So under Vertex Map, run the Weight tool, set the value to 100%, and click in the viewport. And if we go to the Vertex Map view, you can see the whole fish is red. So now we have to remove the weight from the areas that we want to be soft. So just to make this easier to see, go to Advanced OpenGL, hit O and activate Show Weight Maps. Let's turn Symmetry on the X, got Polygon Mode. So we'll just select this fin, so select those polygons, hold down Shift and hit the up arrow to expand the selection. Then if we go to the right hand view, we can run a linear fall off, and we'll just place that fall off across the base of the fin, and go to Vertex Map, Weight Tool, and we'll set the value to 0, and then click in the viewport. And you may need to just adjust that fall off so it's blending nicely from the body into the fin. So you need to do the same thing for the tail fin, the anal fin, and also the pectoral fin. And then we can come back over to the Animate tab. And if you select the soft body influence, we then need to set that weight map as a pin map. So under pin map, select pin map, and now we're ready to run the simulation. So just come over to Recoil and hit run. So when the simulation is finished, we can now bake the entire animation down to an MDD file. So select the rockfish mesh item, go down to Toolbox, hit Export MDD, select the folder where you want the MDD file to be saved, and away it goes. So when the MDD file is finished saving, you can then open up the starting scene for this video. This just contains the single mesh item for the rockfish, and just right click, add deformer, and under influences select MDD influence, and then find the MDD file that was saved, click open, and now that animation is baked into the fish.